Hey guys, I'm back. So today we're going to be talking about some explosions, and you get to see them. Headphone users be warned, it's loud. So I filmed every explosion: capacitors, cap discharge power supply, some homemade rocket engines, real rocket engines, and electrolysis hydrogen oxygen explosions in 60 frames per second HD, and then 240 frames per second. So let's watch the caps in HD. Whoa. And then this is frame by frame afterwards. So you can see it's way, way too fast. And so then I filmed it in the high speed, hoping to capture it. And it took me all of these ones that you're about to see to get a good explosion where the cap just blew itself to bits and blew the top off again. Some of them were pretty cool and they shot all over the place, but I had to wait for this one. So you can see even at 240 frames per second, it's still too fast, slow. So I slowed it down to frame by frame in this example, and you can see that it's still a little fast, but... So I invite you to pause any of these clips to go frame by frame. But this is my cap discharge power supply. So this is about 22, 23 joules approximately, which is about the energy in half of a potato chip, released in about a microsecond. And as you can see in this picture, what I've done is I've actually taken two polarizers and polarized it because it's way too bright, and created this blue stuff, which I believe is plasma. Wow, that really welded it tight. That's pretty nasty. And so here I've actually taken the polarizers, taped them over the camera lens, but I've rotated them a little bit less than last time. So you can see on the right, you can see the caps. But the problem is the explosion is still too bright to see the actual plasma. So that first example, you can rewind and go to earlier, but that's going to be your best bet to see the plasma. And here you can see some of the plasma is actually wrapped around the screw. So I believe this is my proof that it is plasma, is that it's actually wrapping around the magnetic field. But you can see normally without the polarizers, it's pretty much way too bright to see. And it's very loud. So here you can see the LED light up, and then the rest of the energy is gone. And you can see this is what it looks like without the polarizers in a freeze frame at the minute of the explosion. It's just way too bright. The screen is almost entirely white. And using this ruler in the background, I actually calculated the speed of these sparks. And you could do so yourself, but because it's 240 frames per second, you can calculate the length of time of one frame, and then how fast the sparks are going, and they're going at a minimum of 80 miles per hour.
3, 2, 1. Ready.
This is a model rocket, B46 rocket engine. And sorry for the scratches and white sort of mist covering the screen. I had to cover it with a plexiglass sheet so that the camera didn't get damaged. This is sort of a homemade rocket engine. It's done by just leaving a bottle of 95% isopropyl alcohol just sitting in the cabinet for a day, and then light the top of it, and the alcohol vapor will actually burn down like a rocket engine. So you can see this is slowed down at 60 frames per second. And it burns like a rocket engine, and the alcohol vapor just burns down the container. So this is sort of like a non-explosive fuel-air mixture. So speaking of fuel-air mixtures, here I am doing some electrolysis on water, and so the electrode on the left is producing hydrogen gas because it's the negative electrode, so the H plus ions are going to be attracted to the negative electrode and get the electrons from there, because the electrons flow from negative to positive. But you can see the electrode on the right is supposed to be releasing oxygen gas, but not very much gas is coming off of it. And that's because it's actually oxidizing the ions in the water. So like calcium, iron, magnesium ions that are naturally in the water. And so you can see I used it here to fill this balloon, and I'm just using salt water. So there is some chloride produced. And this is sort of the result just by putting it in an open container. By filling it into the top half of a bottle, you can see the reaction here. I believe the reason that you can actually see this reaction and the reason it takes place so slowly is because there's very, very little oxygen actually in this environment. It's mostly hydrogen because the oxygen itself is used up oxidizing the metal ions and possibly the hydrochloric acid that's formed because I use salt as a catalyst. So here's another good explosion. And again, you can actually see it in this time we're at 60 frames per second because of the hydrogen.